Welcome to this video. In this video, we are going to continue with the basic syntax in Python. The last time we looked at some basic syntax like variable and data types. We look at list, we look at how to create list, how to slice, how to append, and so on and so forth. So we are going to continue. And to the first one we are going to consider today is dictionary. So dictionaries are an ordered collection of key value pairs. They are useful for storing data that is indexed by unique keys rather than sequential numbers. So to create a dictionary, let's create a dictionary and give it as a person. Let me paste this code. We have a person. Let me change this person to, let's say, student. We are creating a dictionary that contains information about a student. So the name of the student is Alice. The age of the student is 25. We can add the email of the student or the student ID. Let's add student ID here. Student ID. Student ID is 0 is 101. And email, or let's say department. The student department is data science department. And so we now say print student. Print student's name. And let's run that. It has return Alice for us. So we can also say print student. We can say print student department. If we run department, how did I define department? Student is in the first S is uppercase. Python is uppercase sensitive. So I have to change this to student and then run. So it has given us the department is data science. So that is how you define a dictionary, and then you call out any value, any unique value in that dictionary. So whenever if we call If you say print student, it will bring out all the information about the student. Let's do that. Print student. Print student. If you just say print student, now it will give you all the information that are contained in the student. So you have the student ID is 101, the name is Alice, age 25, department is data science. So that is how you create a dictionary. You can modify the dictionary you created. For instance, now you can say that student, you modify student by changing, let's say student, and you now say age. You discover that the age is not correct, so you now make changes, and you say the age is now 27 instead of 25. Now you modify the student age to be 27. So let's run that, and let's say print student now to see what will happen. Print student and run. So the age now is 27, it's no longer 25. That is how you can modify a particular aspect of a dictionary. You can as well add a particular value. You can add values in the dictionaries. For example, now you can say that student, let me copy this. So you now say student, you now add, maybe let's say you add CGPA. CGPA, and the CGPA of the student is 3.67. The student CGPA is now 3.67. So if we run this, you can see that CGPA is now added to the dictionary. So you can create any type of dictionary. You can create a dictionary as a customer, maybe a customer in the bank, and then you assign like customer account number, the account name, the residential address, the email address, and all of that. So you create that using the the syntax in Python called dictionary. So another data type is a tuple. A tuple is an ordered immutable collection of items. Items in a tuple can be different data types. You can have strings, you can have integer, you can have float, you can have boolean data types. So the key characteristics of a tuple include it is ordered. Tuples maintain the order of elements, so you can access element using the index. And another characteristic is that it is immutable. Once you have created uh, once you have created a tuple, you cannot modify it. You cannot add or remove items in a tuple. And it is hashable. It can be used as dictionaries if they contain only hashable items. So we can define a tuple like this. We define a tuple and call it coordinate. And it has a coordinate from 10, 20. So if we say print coordinates at position 1, it gives us 20. Another example of coordinates that we can consider, we can use another example of tuple. We can use tuple to create a date. For example, now if you want your if your the users if the users to fill a form and they should have fill it in a particular order of date, you can use tuple to create that. Example now, we say that date is 2025 and the month is the first month, that is January, and the date is 8. So this particular order cannot be, you cannot change it later on. So this is an example of this. So now we can say print date, and then you specify it that it should print only the day. That is, if you want only the day, you put position 2, and it will return the day of the week or the day of the month for you. So if you print date position 3, it will return 8. That is the day that you are interested. So you can use, there are a lot of many things that you can use tuple to create. You can use tuple also to configure server, something like this. A server configuration, you put it, this is IP address. You put your IP address like this, that cannot be ordered, that cannot be changed. You configure your IP address at 120 port 127.0.0 like that. So these are various examples you can use and, and store them in a tuple. Another data type is a set. Set is an ordered, mutable, and unindexed collection of unique elements. Unlike a tuple that you cannot change, set can be interchanged. The order in which you define a set does not count. So sets are often used to eliminate duplicate items or perform mathematical set operation. Because in set, if you list Moses at position 1 and you went ahead and list Moses again on position 10, set will not will in set operation, wherever you see where Moses appear more than as many times as Moses appear, it will consider it as a unique element. It does not count. But in tuple, if you list Moses as position 2 and wait and put Moses on position 10 again, it will take tuple will consider it as separate items. Unlike in set, set count only once. If you count Moses and see Moses again, it still consider it as a Moses that it counted in the previous time. So let's look at how we can create a set. To create a set, you use curly bracket to create a set. Why for tuple we use open bracket, in a set we use curly rather you use curly bracket to create a set. Example, let's define a set of furnitures like this. You say furniture, you have bed, chair, table, wardrobe, stool, and so on. To define an empty set, you just use the word set and then put open bracket and leave it. So it now consider it this is an empty set. So if we say if you call empty set now, it will return nothing for you. Let's do it. Empty set. If you call empty set and run, it will just give us set with nothing inside. Another thing you can do, you can add an element in the set. Like in the set furniture, you can say furniture. Furniture now is equals to furniture dot add, and then specify what you want to add. Let's say we want to add which type of furniture can we add? Say just add something. Furniture dot add cupboard. Furniture dot add cupboard. Close the bracket. So if we call furniture now, let's print furniture. Print furniture. Return none for us. So you say furniture dot add, then you add the item you want to add and then print it. So now we have cupboard as part of the set. And you can see that it returns the value not in the order that we created. So set can return value at any position. Stood was the last item here, but we returned stood as the first and bed as the second. So that is how we can create um, set and add element. You can also remove a particular element in the set. To remove a particular element, you can say here now you say furniture dot remove and then you specify the name of the element you want to remove. Suppose you want to remove bed and then you type bed. So now if we call furniture, if we say print furniture, we will not be able to see bed again. Print print furniture, and there is no bed anymore. So that is how you can remove an element in a set. Another thing you can do is to check for membership, to check whether a particular, supposing you have a large set of elements, you cannot just look at it by mere looking, and you are doubting whether a particular element is in the set or not. So to check, you will now say print, like here now our set is furniture, so you say print furniture, print whether you want to know whether bed is in furniture, print bed in furniture. And if we run this, it will give us false because we remove bed. You see, it's giving us false because bed is no longer a member of the furniture. If we can change this to chair, if we change it to chair and run it, it give us true because chair is still in the furniture. So that those are the various operations. You can create a set, you can create a null set, you can add value to it, you can remove, you can check for membership, and so on and so forth. Another thing we want to look at now is file handling, how to handle file in Python. Python makes it simple to work with different files like CSV file, HTML, and many other file types. So let's look at how we can handle files in Python. So then we can write into a file and then read the file using this method. So let's press this code here and see. So to write to a file, you say open, then you give a name of the text. You say example.txt. This txt means text. It will now take it that what you're writing is a text. You can give it any name, whether example or any name of your text. The W here is telling Python that you are writing a file, and then you give it the name file. You can give it any name. So you now say file.write, and what you are writing is that hello world. You can write anything. You can say hello Alice or hello Bobby, whatever you may want to write. So Python will now write this for you. So you can now read what you have written. You can say with open example, that example.txt that you write. Now R here means read. For to write, you use W. For reading, we use R, and you read as file. Then define another variable and call it content. And then content is equal to file.read. So print the content that you have defined. Then if you print this, you will see this value that you wrote here, this hello world. So let's run this and see. So you see the result has given us hello world. So that is how you can write into a file and then also read the file. Another syntax in Python that we'll look at is indentation. Python uses indentation to define blocks of code instead of using brackets. Example, consider the following code. We have a code like this. If age is greater than 18, if age is greater than 18, print adult. So if we run this, this is a type of indentation. So you can use this to define block of codes. It has given us error. Let me see. Okay, we have not defined age. We have to define the variable age before using it. So let's define it on top here. We say that let age let age be 19. So we say if age is greater than adult. To run this, it is of adult. Now, another type of control structure is a loop. Loops are used to repeat a block of code multiple times, either for a set of number or iterations, either for a set of number of iterations or whether a condition is true. Python provides two main types of loops. We have for loop, and it is used when the number of iteration is known or when iterating over a sequence. And then the second one is while loop. This one is used when the condition for looping depends on a runtime evaluation. So let's look at for loop. So let's define a code using for loop. We have a code like this. We define a list of fruits. We have apple, banana, cherry. Then we say that for fruit in fruits, for any fruit in the list of fruits, print that particular fruit, that particular fruit. So this will now iterate and print all the fruits that we have in the list of fruit. So if we run this, it will give us all the list of the fruits that we have here. So this is one example. Let's look at another example. Look at this example now. Consider a certain range. You say that for I in the range of 1,6, that is numbers, you define numbers starting from 1 to 5, print I. So this we iterate over all the values in this range. So if we run this, it will give us the numbers from 1 to 5. So this is the result. So if we say, if we can say for I in 1,10, it will now return all the numbers between 1 and 10, that is 1 to 9. There is there's an apostrophe there. These are the values that, so you can use for to define, to select values in a given range or in a list of items and so on. Another type of loop is while loop. So while loop repeats iteration as long as the condition is true. It keeps iterating whenever the condition is true. When the condition is false, then it stops. For example, now you can use while loop to count. You give a certain condition where the counting should count until it reaches. Look at this. You see now, you define a count to be 0, and then you say while count is less than 5, keep counting until the condition is met. That is when the count is less than 5. So as far as it's less than 5, it will keep counting. So if we say print count and count uh, plus equals to 1, that means for each count you keep adding. When count is 1, you add another 1, the count will go to 2. When you get to 2, you add to go to 3 until the condition where you say count is less than 5 is met before the counting will stop. So if we run this, you see that it has given us the count from 0 to 4. So if we, supposing we define, let's define another one like this. Let's this one, while count is less than than 10. You see, it counts from 0 to 9. So that is for while loop. So we have what is called nested loop. A loop can be nested within another loop. What does it mean? It means that you can define a loop inside another loop. Look at this example. We have this code here for I in the range of 1,4. Let's say, let's put this to be 1,10. Then this is a loop for I in the range of 1,10. Then we define another loop again for j in the range of 1,10. Print a function of I times j. The function of I cross j equals to I times j. So whenever we find I in the range of 1 and 10, and then you also find j in the same range, then you multiply it. This is a function that is used to define multiplication table. This is a multiplication table function. So if we print this will give you multiplication table. So you see, so you have multiplication table 1 times 1, 1 times 2, up to 1 times 9. Then we also have it gives you multiplication table to up to 9 multiplication table. So this is a function that you can use to generate multiplication table. So for each value I in the interval, you multiply it by j. So if we supposing we say um, j is 1, so let's change this to 1 comma 12. Now it will give us multiplication table up to 12. It gives us a multiplication table to 11 rather. If you want it to be up to 12, you have to make it 13 because it does not count the last one here. The range take from 1 to 11. And we can change this, you can make let this one be 13 also, so that it will give us 13 from multiplication 1 to 12. Let this be 13. So let's run it. So it gives us multiplication 1 to 12. For multiplication of 2 is 2 times 1, 2, 2 times 2, 2 times 3, 6, like that, up to 12. And it gives us up to the 12th table. So that is how you can use a loop inside another loop. And it is called a nested loop. Another use case for loop is data processing. You can apply operations on data sets. For example, if you have a data like this, you have numbers from 1 to 10, and then you define a function of a square that you multiply each x by itself. That is a square for each x in the numbers that we have defined here. So for each, if you take 1, you do 1 square, 2, you do 2 square, like that. So when you print this, you will see the result. You can see you have 1, 4, up to 100. So each number in the numbers that we define, you square them. So that is, you can apply, if you have a data set, you can use loop to define particular um, operations that you want to. You can do you can take the square root and so on and so forth. So there are best practices that you have to observe using loop to get optimized results. You have to avoid infinite loops. Enter loop conditions will eventually become false. Ensure that loop conditions will eventually become false. It should not be finite. The condition should not continue to be true infinitely. And then you have to optimize performance. You have to avoid excessive nesting of loops, because if you loop another loop into excessive looping, it will the processing time will be longer. It will take longer time for you to process. And then comprehension, you should not choose a loop that is faster and cleaner when it is not comprehensive. So even if it requires taking longer time, comprehension should not be sacrificed for speed and clean code. So these are some of the best practices you have to observe when you are using loop while coding. The next thing we're looking at now is function. A function in Python is a reusable block of code that performs specific tasks. Functions are fundamental for code modularity, reusability, and maintaining clean and organized code. That is, if you define a function, you can use it over and over. And functions are defined using the DEF as a, that is, you define a function using the code DEF. We have three types of functions. We have built-in functions. These are predefined functions provided by Python, like print, that is used to show the results of a code, and length. This one is to show the length of a given data, and then the data type. So these are inbuilt functions. And then we also have user-defined functions. These are custom functions that are created by the programmers. Then we have what is called lambda functions. These are anonymous single line functions used for short operations. So we'll be looking at them. We use the keyword def to define a function. For example, you say define the function called greet, and then this is how we define it: print hello world. So to return this function, you just say you call greet, and then it gives you hello world. So when you call greet as is defined, then it returns hello world to you. So you can define any function like that and call it anywhere in your code. So we have functions with parameters. A function can take on parameters. Those parameters is what we call input to make them flexible. For example, now if you can define a function, the same function greet, but it will be assigned with a parameter. We define greet use. We just open that when you print it, and use the load. So is statement. The result statement is one of from the